functional groups and classes of organic compounds. Organic chemistry is built on a key concept, functional group. A functional group is a specific group of atoms within a molecule that determines the chemical properties of that particular molecule. By understanding functional groups and the different classes of organic compounds, you can understand how a molecule behaves, the properties of the molecule, the reactions of the molecule, and how they can be used in different fields. We'll be looking at some classes of organic compounds and the functional group. Number one is alkanes. Alkanes are the simplest hydrocarbons. They are saturated hydrocarbons with general molecular formula CnH2n plus 2. Alkane doesn't have functional group, only the carbon-carbon single bond and carbon to hydrogen bond. Alkanes are simplest organic compounds. They are made entirely of carbon and hydrogen atoms, with carbon atoms linked by single bond. Alkanes are saturated hydrocarbons. Each carbon is saturated with hydrogen atoms, meaning no double bond, no triple bond. Alkanes are found in fuels like natural gas, methane, and gasoline mixture of some alkanes. And when alkanes are born, methane is born to heat at home, and gasoline and the rest. So the alkanes are relatively inert compared to other organic compounds, but they undergo some reactions like combustion. In the case where propane undergoes combustion to give carbon dioxide and water, they also undergo halogenation to give haloalkanes. Alkane is another hydrocarbon, one of the classes of organic compounds. Alkanes with general molecular formula of CnH2n are unsaturated hydrocarbons with double bond, and their functional group also is that carbon to carbon double bond. Alkanes contain carbon to carbon double bond, which makes them unsaturated, and this means that they can undergo reactions that alkanes cannot undergo, and the double bond is a point of high reactivity where other atoms can add to the molecule. So alkanes are used in the production of plastics like polyethylene and some chemical solvents. They are found in nature as ethene in plant hormones that triggers fruit ripening. Some examples of alkanes are ethene, propene, butene, and so on. So alkane, as an unsaturated hydrocarbon, undergoes addition reaction in the place of hydrogenation. That's addition of hydrogen to alkane will give alkanes in the presence of metal catalysts like nickel, platinum, or palladium. Halogenation will give dihaloalkanes, for example, ethene, bromine, to give dibromoethane, onto dibromoethane. You can also undergo hydration reaction to give alkanone. Also, alkyne are unsaturated hydrocarbons with triple bond as the functional group with general molecular formula of CnH2n-2. These hydrocarbons are unsaturated with triple bonds, which makes them to be more reactive. Their high reactivity allowed them to undergo a variety of chemical reactions. Like the most common of it, as the first member, happen to be ethine, that's C2H2 as acetylene, is used in welding and is also used as building blocks in organic synthesis. Some example, ethine, propine, and they undergo addition reaction. Hydrogenation is one of it, similar to alkane, then hydration to give aldehyde. Alkanone are organic compounds with OH group, that's hydroxy group as functional group, which makes them to have the molecular formula of ROH. R in this case stands for alkyl, which is CnH2n plus 1. The hydroxy group in this alkanol is responsible for the polar nature of alkanol, making them more soluble in water than hydrocarbons. Ethanol, for example, is the alcohol in alcoholic beverages. Methanol is used as solvent and as fuel. So alkanol is alcohol, that's ethanol, also play essential role in biological processes. Alkanol, for example, like glycerol, is used in the making of soap. Alkanol undergoes dehydration reaction to give alkene in the presence of acid. It also undergoes oxidation. That means alkanol can be oxidized to form aldehyde or ketone or carboxylic acid. Yes, aldehyde and ketone, these are carbonyl compounds. Their functional group is C double bond O, which happen to be carbonyl. Aldehyde and ketones both contain carbonyl group, but they differ in where that group is located in the molecule. For aldehyde, the carbonyl group is at the end of the carbon chain. For ketone, the carbonyl group is within the carbon chain. Aldehyde and ketones are common fragrances and flavors. Formaldehyde, for example, is a disinfectant and preservative. while acetone is widely used as solvents, for example in nail polish remover. Their reactions, they undergo reduction and oxidation. Aldehydes and ketone can be reduced to form alkanol in presence of nickel catalyst. They can also be oxidized to form carboxylic acid. That's aldehyde in this case can be oxidized to form carboxylic acid, but ketone do not undergo this reaction. It is suffice to say that primary alkanol forms aldehyde, secondary alkanol forms ketone. Carboxylic acid is another class of organic compound. In fact, carboxylic acid is referred to as organic acid with the general molecular formula of RCOH. The carboxyl group there, that COH, is the functional group, which consists of both carbonyl group and the hydroxyl group, both attached to the same carbon atom. These compounds, the carboxylic acid, are acidic because they can donate hydrogen ion in water. An example of carboxylic acid is acetic acid, which is found in vinegar. The citric acid is found in citrus, fruit. Some drugs also contain carboxylic acid like aspirin, benzoic acid as food preservatives, and so on. Because carboxylic acid is an organic acid, it undergoes neutralization, whereby it reacts with alkali to give salt and water. It also undergo esterification, which happens to be the reaction of carboxylic acid with alkanol in the presence of acid catalyst to form ester. So, ethanoic acid reacting with methanol to form ethyl ethanate. Organic base, that's amines, with general molecular formula of RNH2. In the case of primary amine. Secondary amine will have one replaceable hydrogen, that's NH, and tertiary will not have any replaceable hydrogen. And also, the functional group is amino group, that's NH2. Amine, a derivative of ammonia, shows their basic nature, where one or more hydrogen atoms are replaced by organic group, alkyl or aryl group. Aryl group are aromatic, while alkyl group are aliphatic. So amines are basic in nature because of the nitrogen atom that can accept a proton. Amines are found in amino acid, which happen to be the building block of proteins and some other things in nature. Some examples are aniline, which is used in manufacture of dye, methylaniline in pharmaceutical production. Amine undergoes neutralization with acid to give ammonium salt. Also, ester, which is a product of the reaction of carboxylic acid and alkanol, is they are sweet-smelling organic compounds with general molecular formula of RCOOR. The R there could be alkyl or aryl, where the ester group is COOR, that's carboxyl group, and the alkyl group, which replace the hydrogen, replaceable hydrogen in the hydroxyl group. So where do we find the ester? Esters are present in natural sources like fats and oil. In the case of triester of glycerol and fatty acid, they have fruity smell, which makes them to be widely used in perfumes, in flavoring, and as solvent, like ethyl acetate, and so on. So ester can participate in esterification. They are derived through esterification. That means it can be hydrolyzed back to alkanoic acid and ethanol, which is a reverse reaction of the esterification reaction. The hydrolysis could be acidic hydrolysis and could also be basic hydrolysis. It undergoes saponification to give salt and triglyceride, as the case may be. Amide group are derivative of carboxylic acid 2, in which the functional group is CONH2, the carboxyl group and the amine group. Primary amide with 2 replaceable hydrogen, secondary amide with 1 replaceable hydrogen, while tertiary doesn't have replaceable hydrogen. All those replaceable hydrogen have been substituted with the aryl or alkyl group, as the case may be. Amide are found in proteins where they link amino acid to form long chain polypeptide. So nylon are synthetic amide used in the production of textile or protective gel. Example of amide are acetamide, which are used as plasticizer, benzamide used in organic synthesis, and as precursor for certain pharmaceuticals. The reactivity of amide similarly does not undergo hydrolysis, acidic or basic. It could also be dehydrated to form nitrites. Nitrites with general molecular formula RCN. The CN there are the cyano. The cyano group is carbon triple bonded to a nitrogen atom. And this triple bond gives nitride unique chemical properties that make them versatile in organic synthesis. Nitrides are used in production of acrylonitrile, a precursor for polymers such as polyacrylonitrile, which is used in fibers. They are also used in the manufacture of agrochemicals, pharmaceutical products. So acetonitrile, an example of nitride, the acrylonitrile, also they all undergo hydrolysis. They undergo acidic hydrolysis to give carboxylic acid and ammonium salt. Also reduction, which can produce you can produce a primary amine. Ether is another organic compound. These ethers have general molecular formula of ROR, where the two alkyl groups are bonded with oxygen. They are used as solvents in organic reactions. Ethers are used in medical and industrial applications. They are like diethyl ether is used as an anesthetic. THF, that's tetrahydrofuran, also used in the lab as a good organic solvent, and they undergo cleavage, meaning that ether can be cleaved by strong acid to form alkanol and acrylate. Then lastly, anhydride. These highly reactive organic compounds have the general molecular formula of RCOO, OCOR. They are derived from two carboxylic acid molecules by the removal of a water molecule, and they are highly reactive. And anhydrides are used in the production of acetylating agents like acetic anhydride for manufacturing aspirin, and some are used in the manufacture of cellulose acetate. They undergo reactions like acylation, hydrolysis. These functional groups and their associated classes of organic compounds are essential for understanding the characteristics and the reactivity of this compound.